2, what do we get there? So x would equal -6. So that would be our lowest value. We could actually plug in a -6 because if we did, it would give us a 0 right here, which would be the lowest we could have. And so the upper number that we could have for this would be 5. So we would have x over 2 plus 3 equals 5. And we would subtract the 3 here. So x over 2 would equal 2. And we would multiply both sides by 2. So x would equal 4. So domain of h would equal -6 less than or equal to x less than or equal to 4, or you could write it like this, -6 to 4. Either one. That's fine. It'd be at least 2. Probably 2.
So B would just be 4.
No. Alright, so how does this? Yes, but the H, we're talking about H, not F. So this will give us values because when we plug numbers in here, if I plug in -6, it would give me a 0 there in the numerator. So it'd be the integral from 0 to 0, the area under the curve from 0 to 0 of F. Right. And then 5 would be, if you plug in 4, it would give you 5, which would be the highest you could have. Any number in between there is going to give you something between 0 and 5 where you can actually find it. Right. Right.
Wait, so if you plug in 0, it's for F of P, right?
If you're plugging in these values, you're plugging it into H right here to see if it will work. So like -6, if we plugged in -6 here.
Oh, you're just changing the integration to match.
She's finding the minimum and the maximum and saying that anything else will be in between.
Right.
Yeah.
Okay. All right.
It's pretty simple.
Okay.
Cool.
Okay. So, be really careful here and make sure you pay attention to what they're asking for. They're asking for H prime of 2. So we're not plugging 2 into H. We're doing H prime, which means we need to find H prime of X first. Almost just takes away the integral. So when we take the derivative of this, it gets rid of the integral, which just gives us f of x. But we have to multiply by the derivative of this top limit of integration. Oh, I'm sorry. Yes, sorry, I did that wrong. So when we integrate here, our upper limit goes right here for our t. And then we multiply by the derivative of that. So it would look like this. We'll have f of x over 2 plus 3. What would the derivative of x over 2 plus 3 be? 1/2. Because x over 2 is the same thing as having 1/2 times x. Yes. Now, I don't think you'll see anywhere this happens. If your lower limit also had an x, then we couldn't apply this rule. I don't think you'll see anywhere that happens, but most of the time it's going to be. But it could be any number. It doesn't have to be 0. It could be 7. It could be 10. It could be negative 1,000. As long as it's a number, then you kind of ignore it. Okay. All right here.
That's it.
All right, so that's h prime of x. That's all for h prime of x. You'll definitely get a point for that, possibly 2 on this, since this is only since this has only got 3 parts to this question, I think, right? Yeah.
No,
All right, that's h prime of x. Then we have to find h prime of 2. You can't just leave it on this one because we can't leave it with f of something there. You have to show that you know what f is. So we got f of 4 times 1/2. F of 4, we're just going to read off of the graph. So at 4, what's our y coordinate? -3. So we will get -3 halves. Okay, so C says at what x is h of x a minimum? Show the analysis that leads to your conclusion. All right, so it's asking us about h. It is not asking us about just f. So we cannot just look at the graph and tell. And in fact, for this one, we have to do more than just look at the graph, because if h prime equals f, equals f of x, then we can just look at the graph. But here, h prime does not just equal our f of x. So remind me, let's go way back to when we were just looking at graphs. How can we tell that we have a minimum? Negative to positive will give us a relative minimum. Does this one ask for relative minimum? If it says a minimum, assume absolute. So we would also have to test the endpoints for this one as well. But we need to see if we have critical points in the middle, right? So critical points, how do we find those critical points in the middle where maybe it switches? We're going to see where the derivative equals 0. So we need to take h prime of x, which we just found. I'm going to put that 1/2 out front there. And we need to set that equal to 0. So the 1/2 doesn't really change anything. You can multiply by 2 to get rid of it. So, hold on a second. I don't know if I did my key right for this. Okay. Never mind. I did. I just forgot doing it. Okay. Alright, so we've got to think about when this is f of x over 2 plus 3 is going to equal 0. So let's go up here. So it's going to happen whenever so we're looking for where our y coordinate is 0, which happens at 2. So right here we have 0 f of 2. I'm sorry. I could write this point as 2, 0, or I could write it as 2 f of 2. Right? F of 2 would just mean the y coordinate whenever the y coordinate that I have whenever x equals 2. So, at 2, my y coordinate is going to be 0. So I want the stuff on the inside of this right here to equal 2, so that I will have f of 2, which has a y coordinate of 0. So I am going to say x over 2 plus 3 needs to equal 2. You have to write pretty much everything I've written. So if I subtract the 3, I've got x over 2 equals negative 1, and I can multiply both sides by 2. And so x equals negative 2. And that is going to be a critical point. So we have 3 points that we need to check. We need to check negative, was it 6 or 4? Negative 6, which was one end of our domain. Positive 4, which is the other end of our domain. And then negative 2, which is the point, our critical point in between. So, if we're not going to be able to get exact values. But if we do, we actually can find an exact value for this one. H of negative 4 is going to be the integral, negative 6. I keep getting the 4s and 6s mixed up. It's going to be the integral from 0 to negative 6 over 2 plus 3. Right, we're plugging in x. We're using this equation right here. We're plugging in x for that of f of t dt. And negative 6 over 2 plus 3 is 0, so it's the integral from 0 to 0 of f of t dt. And anytime we integrate from a limit to that same number, we just get 0. So I can't actually find the exact value of that. Let's try h of negative 2. Okay, so same thing we just did. We're going to integrate from 0 to negative 2 over 2 plus 3 of f of t dt, which is going to be the integral from 0 to 2 of f of t dt. All right, let's look up here at the graph for that. There's no way you're going to be able to find the exact value for that, but I do know it's positive. I know it's positive because that area there that we're looking at, this area right here is above the curve. Right, so while I can't tell exactly what it is, I know it's greater than 0, and I'm going to put over here because f lies above the x-axis for 0 to 2. Yes, so that cannot be a minimum because 0 would be less than that. So this is not our minimum point. Yes, you do have to say this out to the side. Yes. Yes. Because they have to, you have to show them how you know that's positive. I would put something about that being above the, that area being above the x-axis. Okay. Then we need to figure out h of 4, which is going to be the integral from 0 to 4 over 2 plus 3 of f of t dt. And that is going to be our integral from 0 to 5 of f of t dt. Alright, so if we look up here at the graph, we're talking about the entire function. So we got that area above the curve and this area over here below the curve. Okay, how do we know it's going to be negative? That area underneath the curve is greater. So and they'll give, if they give you one like this where you can't actually figure it out, they'll give you one that's clearly different there, so you can tell. So we have to say that this is less than 0, and we have to tell why. We know this. I would probably say the area under the curve from 0 to 2 is less than the area Yeah. And really, I see what you're saying right here. You could, that is less than the area between, you could, if you want to avoid that under-over sort of issue right here for that second part, you could say between the curve and the x-axis from 2 to 5. I think if you're like, oh, that's way too many words, I don't want to write that out, I think you probably could say between the curve and the x-axis. And you really could have said that for both, because the area between the curve and the x-axis from 0 to 2 is less than the area. Instead of saying over or under, you could say that, because that's what we're doing there. It's the area between the curve and wherever the x-axis is. So we're finding, so the integral tells us to find the area under the curve. And so when we plug in 4, it would plug in a 4 for our x right here. So we're really finding the integral from 0 to 5 of f of t dt. So that means the area between the curve and the x-axis. A lot of times I'll say area under the curve, but area between the curve and the x-axis from 0 to 5. So on the graph, this yellow area here would be our area from 0 to 2. It's going to be positive because it's above the x-axis. The area right here is from 2 to 5 because it's below the x-axis, it's negative. So whenever you find the area from 0 all the way to 5, you would just add those two together. And since this one is larger, you're going to have a positive number minus a bigger number here, which is going to give you a negative overall. Yes, it's not this graph. The minimum occurs over here at the end point. Because this, yes. But it's not of this graph. You're not seeing the graph that they're asking you about.
You're asking about a hypothetical.
they're asking about this graph we do not have a graph for. So we have to use, so we have to work this purely from like our derivative sort of standpoint, because we don't have a graph that we can look at. Because our derivative of h is not the graph of f, it's this 1/2 f of x over 2 plus 3, which we don't have the graph for. If we wanted to think about what it's going to look like, it's going to be moved to the left some and compressed, expanded horizontally, compressed vertically. Like, it would be really hard to think about what that graph looks like. So we have to think of it like we take our derivative, we set that derivative equal to 0. Wherever that happens, that gives us our critical point. And then with anytime it says just a minimum, it doesn't say relative with it, then it's asking for absolute minimum. So you're going to find the value of h at the endpoints and also that critical point. So it's not so much looking at the graph as seeing which one of these three values would be the lowest. Okay. Okay. So I would, well, let me show. I think instead of saying this, you could say the integral from 0 to 2 of f of t dt is really, it would not hurt to put some absolute value bars there. Is less than the integral from 2 to 5 of f of t dt. And the reason I'm saying absolute value bars is because, like, if we think about doing what Coach Wood would do if he's here. If I estimate here, that looks like it's about 3 blocks right there, so it'd be about a positive 3. All right, don't write, we wouldn't put this on the AP exam, but it looks about a positive 3. If I don't put those absolute value bars, this right here is negative, so that's like, what, 4, 5-ish, 6.5 maybe? So about 6.5, but if I do not put those absolute value bars there, then this expression is technically negative, so it's not less. You're not saying what you mean. I think it's better to write it out in words here because you avoid that. But if you really hate words and would rather use symbols, I think you can do this, and you could do this instead of the words over here. And so I would make the conclusion h of x has a minimum at x equals 4.
So we just circled it. Say no, please.
I think Daniel's asking if you do not write this here at the end. I think you somewhere have to point out that that is the minimum. You have to point out that you understand that whichever one has the lowest value is where the minimum is at. So yes, I mean you might could do this and get away with it, maybe, but I wouldn't. I would just write it as a sentence over here.
That's what I'm saying. It's fitting. Come on. If you're an AP grader, you got to understand that's the minimum.
Well, AP graders grade what you have written, not necessarily what they think you mean. They are not there to interpret. Now, when I grade your FRQs, sometimes I sort of give you the benefit of the doubt, especially if it's one that we're struggling on anyway and you're one of the few people that's almost got it right. But I would love to be an AP grader, although I did not get the grading invitation. Not again this year. Now, there's still a chance, because like the first round of invitations go out because some people may not be able to do it, and then so they'll issue some more later to fill in for the people who rejected it. So there's still a slight chance, but it's not looking good for me this year. So. Okay. questions?
So when if you got a target that's similar to this, and you can tell that some of the values won't give you the minimum, will you still have to solve for them like people that they're like education, negative 6 equals 0?
Yeah, you need to state that because they, once again, are grading what you have put on the paper. So if you don't write that down, they don't know that in your head you eliminated that. And a lot of times they will, especially on absolute maximum or minimum problems, they will, one of the points is for considering the endpoints. So even if they, even if, let's say it was at -2 and you only checked -2 and it ended up being the minimum and you got everything right, if you didn't at least consider the endpoints, they wouldn't give you full credit for that question because absolute could have included those endpoints. So you do need to write that down. Now, what you could probably skip is you could probably skip this step that I'm writing each time because they'll be okay with you plugging that in your head, -6/3 plus 3. So you could probably skip that as long as you show the integral expression that I have over here. General arithmetic, you don't necessarily have to show every step. Just like, of course, if you say x/2 plus 3 equals 2, you need to show that step. But if you jump straight to x equals -2, they're okay with you skipping steps on solving things. But you have to be really clear about your reasoning on the calculus of it. Okay, questions? All right. Think so? I don't choose. The spinner chooses, so we'll see what it becomes. I'm not. I could, but I need 3 options. Yeah. So, a 3. I could let heads be 1, tails be 2, and the edge of the coin be 3.
Let the lowest class grade pick.
All right.
No, I want to eat the power.
All right. No, we are going to.
You will study for it?
This midterm is going to have count 6 times.
All right. So after spring break, we do have to take the midterm. I'm going to give the midterm over 2 days because I want us to do as close to a practice test as we can. So our scheduled day, well, let me just check calendars and make sure there's nothing I need to move this around. So that Friday, which is the 18th, does anyone know of a major conflict on the 18th? Check your... Yes, March 18th. It's the end of the quarter.
No, it's probably the 13th.
Nobody?
There's nothing on the 18th.
Somebody had me sign a permission form for a field trip. It wasn't the 18th, was it?
It was the 19th.
No, it's not the 19th.
19th's a Saturday.
Hold on, I can tell you.